Now 2018 C3. A terrarium is a glass container for soil and plants as shown. Figure C3 shows the plan and elevation of two geometric terrariums. The terrarium on the left is based on a square base pyramid and is shaped as shown. Part A, draw the plan and elevation of this terrarium and determine the dihedral angle between surfaces A and B. So, this part here on the left hand side, just be careful there, your scale is 1:3, so we will divide everything by 3 to scale it down to fit it on our page. Also, you'll see the square base pyramid, or the square we have here, is inclined at 15 degrees. As you will know from junior cert, we can get that 15 degrees by combining our two set squares. And we will begin by drawing the plan of the object. The length of the side then, when scaled down, is 70, and the smaller square in the inside will be 35, so we'll measure in 17.5. Now that then completes our plan and elevation. So the second part of part A is to determine the dihedral angle between surfaces A and B. Now both surfaces are quadrilaterals, so with 4 corners. I only actually need 3 corners, so I'm going to divide both surface A and B into 2 smaller triangular surfaces, like so. I'm also going to label my line of intersection, line 1, 2, and then I'll have corner 3 and 4 on my other 2 surfaces. I'll follow my points down. And then I'm just going to highlight my triangular surfaces. So as you can see, 1, 2, 3 is surface A, 1, 2, 4 is surface B. Next step then for a dihedral angle, we will project 90 degrees to our line of intersection. That line of intersection is actually a 30 degree or 60 degree line. So we can project off there at 30 degrees. Heights from the elevation, as you notice, 2, 3 and 4 are all on the XY line, so I don't need to take any heights. 3 and 4 are perfectly in line, and the only height I need is 0.1. And 1, 2, my line of intersection, I now have the true length of it. So my second stage then for finding the dihedral angle would be to look along that true length line. Now I would go back then my 2 views, so I'd be measuring from the x1, y1 back to the plan. So what I'm going to go and do here is put in a datum line at point 3 there, and I'll measure my distances back from the datum line. And we know at this stage, because we're looking along a true length line, 1, 2, that will just appear as a point in my next view. 3 is on my datum line. So I will get an edge view of both surfaces A and B. And there then is my dihedral angle, which you would measure and indicate. And that is part A complete. And part B, develop the surface C. Now as we can see, surface C is a triangle, an isosceles triangle, because those 2 edges would be equal in length. Now, first of all, that side of the triangle, we can see the true length of that in the plan there, because it is horizontal in the elevation. So what I need to do is find the true length of one of these sides, because we both know they're the same length. So to find the true length of that side, I will rabat the line. So I'm just going to bring a horizontal line. I'll call my apex 0, or point O. Horizontal line there across from O. I will rotate my line around or rebat until it hits it. I will then bring it straight up to the elevation to the same height, and I will then join it back up to O. And there's the true length now of one of the sides of triangular face C. Now, as I've already said, it's an isosceles triangle, so both sides are the same length. So what I'm going to do, I know that line there is a true length already, so I'm just going to rebat the face C down below here. So I'm going to take my true length that I've just found with my compass, and I'll swing it off there from both sides. And that there is my true shape.